All right, you guys, the main module, the initial phase. This is the first ever phase. Before we even have a loop, we need to execute whatever code is at the root level of the module that we're about to run. And it's interesting and very critical to understand that this piece, this phase, this stage, we don't even have a loop yet. i.e., things that are done in the loop, like we're going to see, things like listening, connection establishment, things like that, I/O, won't run here. So if this stage is slow, the listener won't run, the I/O won't run. Most of the stuff that are I/O specific, asynchronous, synchronous is an exception, will be delayed until this thing finish. So just keep that in mind. And let's dive into this. First thing, I'm gonna disappear for the remaining of the lecture because you don't really need to see me here. But here's our. I'm not gonna mention the stages or the phases here. I'm just gonna put question marks, and every single phase I'm gonna reveal it. It's like a video game, if you will. And then I'm not gonna spoil, right, the phases for you. You just every time we're gonna see these phases. We're here. See, it's not part of the loop. We're executing stuff here. And then we're gonna go to this loop here and begin the actual loop. So the initial phase, by definition, runs once, only once. So let's get into it. So all main code execute synchronously. The main module or the initial phase executes synchronously, i.e. one after the other. Pa, da, 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 da. We don't schedule a callback and execute it within the initial phase. If we are registering a callback, it's gonna be the next phases. Here, we're just going one by one. Ta, 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 ta. We're just executing code linearly, synchronously, right? And one by one. So no callbacks. Main loop here is not initialized yet, as I talked about it. And also, this is also called the initial phase, and it runs only once. So, based on that definition, what do you think the output of this will be? Here's I have some code that initializes x with a 1, and then adds 1 and stores a value, and then it registers a timeout for 1 millisecond. And then it does a loop for a million, whatever. What did I do this? This is like boom, boom. By the way, in JavaScript, you can just add underscores. I learned this recently, and it's the same value. It's just easy to read. Easy to tell what this number is. This is 100 million, I think. Yeah, 100 million. So just loop for 100 million, and then print this. So what do you think the output is? All right. Well, the execution happens. This is synchronous. Pop, synchronous. Pop. Timeout. Not in this stage. We're gonna register a callback and move on. So after 1 millisecond, we're supposed to execute that. But guess what? The timers, spoiler alert, is its own phase. But that phase is what? It is by itself. I want you to see my expressions as I talk about this. The timer by itself is a phase. And that phase is in the loop. And the loop is not yet initialized at all. We're still executing what? This initial phase. So I just register and then just move on. And then I synchronously execute this nasty loop, which is just, imagine like it's expensive code that you have in your initial phase. And just running, right? CPU intensive. And then after that, we'll print this. So the question is, will this be printed first? Will this be printed and then should run in 1 millisecond? What do you think the output is? Well, the real output is this will be printed first, and then maybe 3 seconds later, when this loop is finished, that will be printed. And that's exactly what's happening, right? And you understand that. And that's because this code executes in the initial phase, this code executes in the initial phase, this is in the initial phase, this is also in the initial phase, but this is in the next phase, which comes right after the initial phase. It comes right, it's here actually. So we're here, we're stuck here. So we registered the callback and we put it here, but we never got there to actually execute it. We were just busy here. Does that make sense? Here's another thing. Modules often, I'm going to add often here, loads before the main module, before the initial phase. And this really depends whether you're using require and import. And I have a whole lecture about the difference between these two guys. But mostly if you use require, these puppies will load before even executing your code. So as part of the initial phase, we load modules in case of require. Let's not talk about import because import is asynchronous, but essentially that's what's happening when we do that. So the code executes first, and then all of this require and import are loaded, right? The exception is really import is different. So we load these modules before running the main module, the initial phase that we're in, the actual module that we run, right? Because we run node index.js, right? And index.js can reference other modules to actually execute. Those guys actually execute before us. And there are modules that load other modules as well, right? And we'll talk about this when node modules come into the picture, and we'll talk about all this beauty stuff, right? So the trick here is we really need to keep the initial phase as short as possible for performance reasons, right? And the reason is because that makes node spins even faster, right? And the trick here is really we need to know our modules. Like, what are we referencing? What is going on here? If I'm referencing a module, you can measure, by the way, everything. If you have the time, if you have the aptitude, let's say, you can measure how long the module loading modules take, right? So we'll actually do all of that as well. So let's continue. So here's an example. You guys love examples, right? So here's an example, guys. I'm importing a.mjs, and here's a.mjs, right? A.mjs has the following. It loads a.mjs, prints about to load MJS. It does this loop. You'll see, by the way, you'll see this loop everywhere. I love to add it because it shows you what is going on behind the scenes, really. So I'm just doing this. I'm doing an expensive loop, and they just loaded a.mjs, and then that's the actual module that I'm loading, right? And then importing that guy. MJS is basically the new format, right, for modules, right? You're gonna see me use different types here and there, essentially, but it really depends on your coding style and whether, like, of course, the project that you're working on is new or legacy. Sometimes you cannot just switch. And of course, we're referencing the a.mjs before main module, print, doing some operation here, doing the loop, and then end module. So what is the output? You notice that a.mjs is being loaded first, and then the main module comes right after that, right? So whatever you import is going to execute first, then your main module will execute. So it's literally synchronous, one after the other. Yeah, we talked about that. Keeping the initial phase as short as possible is very, very useful because that spins up node faster. And let's talk about summary. I'll remove this animation. So let's summary and then go to a demo. Let's summarize the stuff and go to a demo. Actually get our hands dirty, Disney. Initial phase executes all code synchronously. We saw it like boom, 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 one after the other. The modules are loaded first, all right? And then once all the modules are loaded, we begin executing our stuff. Now, the exception is if you can put the require and the import in the middle and you get interesting situation. And that's not what the slides are for. That's where we go and get our hands dirty and test, right? And play with all this configuration, right? This is where this course, you guys, you get to innovate. There is no pressure. There is no deadline or anything like that. Nobody's watching you behind your back. You know, you're watching this course. You're just learning. You're just curious to learn. Oh, what happened if I put this here? Oh, let me move this up right here. Let's see what happens. And that's what all about. You know, that's what it's all about, guys. You know, it's all about, we forgot how to play. You know, that's what happened. That's what happened. We forgot how to play. As kids, we always used to play with things. You know, as we get older, we get like responsibilities, which I'm not against responsibility, but we get like serious. And we just like, oh, I don't have time to, just like, I just want to get it over with. And that's not an attitude that gets you anywhere, you know? It just becomes an anxious. You become anxious. Like, no. Enjoy. Let's enjoy. Let's have fun. Let's go. Let's go. Open the code. Let's go. Look, we are now in the main module. We close this guy. Open this. What do we have? So we're going to use require. We're going to play a little bit with different values here. And we have a file here, 010. 01 is the next lecture, right? So 010 is requiring b.js, and this / means I am right here where __ file name is, which is whatever I'm running, right? Right in the same path, go and reference /b, which is in the same directory. Go and reference that. I'm not going to zoom in so you can see, right? I am right here. I'm going to run this file. It's going to reference /, means in the same path, reference b.js. And b.js has this loop. We're loading b, loop. And I'm going to show you that you can do something like that. It's so cool. I'm going to change all of this stuff because I just learned about this. So I'm just going to start doing that. And I'm going to push this code. But yeah, you can do that. And this is the next thing. We're going to do this next. But yeah, let's do the... Yeah, let's load a module. Let's run a module and load it. I'm not going to update. Thank you. Not Visual Studio Code. So let's do node. We are at the root. 01, main module, 010a. So just go ahead and run this. What happens? That was so fast, man. I have like a super fast machine, so you can see. We're loading module B, end module B, and then loading module A, end module A. So what happened here is I required B, which B ran first, finished, and then came back. So just so you can see, feel it, I'm going to add a few more zeros here and then run it. Haha, you can feel it now. Oh, no, this is not going to finish, huh? You get the idea, see? I'm loading B, loading B, loading B. Eventually it's going to finish. And then, yeah, this is too much, man. Maybe at least go add 500 million, something like that. Yes, still. Okay. Add an extra zero. 10 million, not, yeah. Yep, you can feel it. All right, you can play with this and see the difference. So we have 100 million. Okay. All right. So loading this, you can see that modules are required and they are loaded first. So let's do some changes here. I'm going to add another module. I'm going to call it c.js and paste. Same thing, module C. Do you guys want me to make this bigger a little bit? Let's do that so you can see it. Yeah, 30 was a little bit better. Okay. Anyway, I'll zoom in when you guys need, so we can see this. Okay, we're loading module C, and how about that? I am going to make, we don't really need you. We'll load you in B, right? In B, I'm gonna load C. So what loads first? Do you see that? C loads first, B loads second, and then A comes later. Sweet. Isn't that cool? All right. So here's what's happening. A load B and B loaded C, and then finally A actually executes. So let's change the game a little bit. What if in B I move this code at the end of B? What you think, guys? Do you think it will change the result? B loads first, C loads second, and then A. So it is literally synchronous, as you can feel it, right? B, loaded B, and then, require C. So where you put the require, and imagine you're requiring, I don't know, fetch or express. It's the same exact thing. Express has synchronous code that will execute, and it will have some asynchronous code that will come to, and it will just, you feel free to play, right? What happens if I do this? If 1 is equal to 2, what do you think? What do you guys happen? It respects if statement. It's just another call when it comes to require. And I don't want to get into the difference between import and require right now. It's too early in the course. I don't want to get you confused. But let's just do that. You see, right? And now, of course, you can play with, and I'm doing silly if statements here, but to get you the idea that, hey, it's require actually respects if statements, right? Sweet. All right, I'm just gonna leave everything as is here, and yeah, and let's go to the other exercise. 0, 1, 1. 0, 1, 1 is the second exercise that I have here, and what it does is, and I made sure to add some comments for you, even so if you go to the scorecard, you can actually read to tell you exactly what is happening here, right? So x equal 1, x plus 1 is set y, simple things, just operations, doing nothing, right? We're setting a timeout that will execute after 1 millisecond, and then we have our stuff. I'll start fixing it. I'll start fixing all this because I just literally learned this at the end of the course. I was like, oh my God, I can do underscore so it become readable. So I start fixing all that, and you'll, by the time you get this source code, you'll see the latest updated. But as you can see through that. So in my main module, I'm loading all the steps, registering a timeout, and then we'll print that. So we've seen this in the slide, right? So we did 0, 1, 0, 1, 1. Boom. You can see that all the time. We print this and then should run in 1 millisecond. Boom. And we're running it. We're going to play with timers, you guys. We're going to play with timers in the second, like actually the one next right after this one, right? But timers are interesting, right? But don't trust it. They are not trustable. So yeah, 1 millisecond, I can make this. Good luck trusting 1 millisecond, right? It's going to take a long time. Yeah, I mean, sometimes the loop is just too fast. Yeah, look at that. You can see that. I did it 1 billion and still fast. I have like the M3 and Pro Max, whatever that thing is. So, and still, again, the whole thing executes in one core, right? Because it's a single threaded execution here. And we'll talk about that. I know I keep saying we'll talk about it, but I swear we'll talk about it, guys. So just take it easy. We'll get all of that. Let's just stop here. I think that's enough importing. We talked about the initial phase where things get executed here. I think that's enough. Yeah. How about we jump into the next lecture?